Okay, so this is my rational function, x squared minus 16 over x squared plus x plus 12. And first of all, in order to be able to graph it, we need to factor the equation down. So x squared minus 16 can be factored into x plus 4 and x minus 4, and x squared plus x plus 12 can be factored into x plus 3 times x plus 4. And since there's both an x plus 4 on the top and the bottom, that means we can cancel it out, leaving us with the whole in the function to be negative 4. So that leaves us with the equation of x minus 4 and x plus 3. So then in order to find the coordinates of the whole, we can plug the whole, which is negative 4, into the remaining equation. So that would be negative 4 minus 4 over negative 4 plus 3, which gives us negative 8 over negative 1, which leaves us with y being 8. So that gives us the coordinate negative 4, 8. Now that we have a whole we can plot on the graph, we need to find the asymptotes. So I started with the horizontal asymptote, and I found it by dividing the whole equation by the highest power of x. So that would be x squared over x squared minus 16 over x squared, all of that over x squared plus x over x squared plus 12 over x squared. And after I simplified that down, everything left with a denominator of x squared. As x gets closer to infinity, all of those numbers get closer to 0, so we can cross them out of the equation. So that left us with 1 over 1, which gives us the point 0, 1 as the horizontal asymptote. So now I found the vertical asymptote, and I did that by finding the zeros of the denominator of the equation, which were x plus 3 and x plus 4. So that leaves x to be negative 3 and negative 4. But since we know that the whole is going to be at negative 4, that means we can't have x equaling negative 4 because there's a hole there. So that leaves us with the vertical asymptote being negative 3, giving us the point negative 3, 0 as an asymptote. Next, I found the y-intercept of the equation, and I did this by letting every x value in the equation equal 0, so then that leaves it to be 0 squared minus 16 over 0 squared plus 0 plus 12. That leaves us with y equals negative 4 over 3, which means that the coordinate of the y-intercept is 0, negative 4 over 3. Then I found the x-intercept, which I did by letting the numerator of the equation equal 0. Then I just solved for x, and that gave me plus 4 and minus 4 to be the x-intercept. However, we have a whole at negative 4, so that cannot be the x-intercept, so that just leaves us with the x-intercept to be positive 4, which is the point 4, 0. Then I drew in the asymptotes on the graph, which we found earlier, the horizontal asymptote at y equals 1 and the vertical asymptote as x equals negative 3. Then I started to make a table of values to find the end behaviors of our graph. So I did this by plugging numbers back into our original equation. So I started with 1,000, plugged that back into the equation, and that gave me 0.998. Then I plugged in negative 1,000 to see what the end behavior would be when x equals negative 1,000, and that gave me 1.0009. Then I decided to use points that were closer to the vertical asymptote, so I plugged negative 2.99 into the original equation, and that gave me negative 699. And then I plugged negative 3.01 into the equation, which gave me 701. Then I drew in the end behaviors of my graph, and then I decided to plot the y-intercept and the x-intercept onto the graph. Then I plotted the hole that I found, which was at negative 4 and 8. And then I plugged in some more x values into the equation just to find more points to plot on the graph to make it look cleaner. So I plugged in negative 2 into the equation, which gave me negative 6. I plugged in negative 5, which gave me 4.5, negative 6, which gave me 3.3 repeating, and negative 8, which gave me 2.4. Then I plotted those points on the graph, and I drew a smooth curve through all of my points. And after I drew in those two lines, that is what my graph of my rational function looked like.